Algebra Review Part 4. This review deals mainly with solving inequalities. This first example says solve and write the answer in interval notation, graph on a number line. So we want to get the x by itself. We need to get rid of the 2 and the -5, so we know we do the subtract 2 first. And because we have the double inequality, we'll subtract 2 from the far left and subtract 2 from the far right. So now we have -25 is less than or equal to -5x is less than 10. Now we'll divide everything by -5. Remember, with inequalities, if you multiply or divide everything by a negative, your inequality symbols flip over. So we're left with +5. Now flip greater than or equal to x greater than or equal to -2. Or if we want to go from smaller to bigger numbers, we can write it as -2 less than or equal to x less than or equal to 5. Interval notation is when you write the start number and the stop number with either parentheses or brackets. And So we want to solve this inequality, write the answer in interval notation, and graph on a number line. And I want to get the x by itself. We want to get rid of the 2 and the -5. So first we get rid of the 2, we subtract 2. And since this is a double inequality, we want to subtract 2 from the far left and from the far right. So now we have -25 less than or equal to -5x less than 10. Now we'll divide everything by -5. And remember, when you multiply or divide an inequality by a negative, the inequality symbols flip over. So now what we have is 5 greater than or equal to x greater than -2. And if we want to rearrange that from smallest to largest number, that would be -2 is less than x is less than or equal to 5. Interval notation is where you write the start number and the stop number with parentheses and brackets. So we're starting at -2 going to 5. If you don't have the equal to part, then you write a parentheses. If you do have the equal to part, you write a bracket. So that's interval notation. And then on the number line, we start at -2, we stop at 5. The x is trapped in between those two numbers. Parentheses on the -2, bracket on the 5. This inequality is a bit trickier. It's been factored. So we have 3 x's that we have to deal with. Set each factor equal to 0 first of all. We're going to find where this expression actually equals 0 to start with. So x equals 0, x plus 6 equals 0, x minus 4 equals 0, and solve each of those. So x equals 0, x equals -6, x equals +4. Now that's where the expression equals 0. We want to know where would it be less than 0. So the way to solve this algebraically is to first set up a number line. And on the number line, we're going to list all of the zeros of our polynomial. So that would be at -6, at 0, and at 4. Then we're going to pick some test numbers around those zeros. And I'm going to write those a little bit smaller. To the left of -6, let's pick -7. In between here, I can pick anything in between -6 and 0. I'm going to choose -1. Between 0 and 4, I'll choose +1. And bigger than 4, I'll choose 5. And let's remember, all the way to the right is positive infinity, to the left is negative infinity. And then I take each one of those little red test numbers, plug it back into the original polynomial, and figure out if the result turns out to be positive or negative. So if I plug in the -7 in for x, that would be a negative value. If I plug the -7 into the x plus 6, -7 plus 6, that's also a negative value. and then plug the negative 7 into x minus 4, that's also a negative value. So I'm multiplying a negative times a negative times a negative, which is negative. Now I do the same thing with the negative 1. Plug negative 1 into that first x, that's negative. Then negative 1 plus 6 is positive. Negative 1 minus 4 is negative. So a negative times a positive times a negative is a positive. Moving to the next test number, positive 1, in for that first x, that's positive. 1 plus 6 is positive. 1 minus 4 is negative. Positive times a negative is negative. And finally, plugging in the 5 for all of the x's gives me a positive, positive, positive. So it's positive. So because the original problem says less than 0, I know that I'm looking for the intervals that are negative. So that happens from negative infinity to negative 6, and it also happens from 0 to 4. So we want to write that in interval notation. We're from negative infinity to negative 6, and then from 0 to 4. The original inequality did not have the equal to, it was just a less than, so I know that's parentheses. And infinity always has parentheses. And then because the two sections are part of the same answer, we use a U for union in the middle. So all numbers that are in between negative infinity and negative 6, and all numbers that are in between 0 and 4 would solve the original inequality. Okay, a little more complicated now. We have a fraction, we have a rational expression. First of all, we want it always to have 0 on the right side. So I'm going to have to start by subtracting 1 from both sides. And then we have 3x plus 5 over x minus 2 minus 1 is greater than or equal to 0. But we have to get all of that combined into just one fraction. So I need a common denominator. It would be x minus 2. And if I put x minus 2 on the bottom, I have to also put x minus 2 on the top. A further complication is that it's a subtraction. I like to kind of seal things off in a parentheses when I've got a subtraction involved to help me remember that the minus goes to both the x and the negative 2. So when I put it all together, I have 3x plus 5 minus x, and then minus a minus 2 is plus 2. It's really easy to mess your signs up on that. And then combining, that's going to give me 2x plus 7 over x minus 2. Now we'll set both the top and the bottom equal to 0 to get just the zeros of this. 2x plus 7 greater than or equal to 0, or rather just equal to 0. And then x minus 2 equal to 0. The bottom actually we'll find out, we're finding out the numbers that cannot be used at all in this problem. I'll talk more about that in just a second. So when I solve 2x plus 7 equals 0, I subtract 7, divide by 2, so x is negative 7 halves, which is negative 3 1/2. And then x add the 2 equals 2. Now, just like on that previous problem, the next step is to do a number line. And I'll put the negative 3 1/2 and the 2 on the number line. And then I'm going to pick some test numbers. Let's try negative 4, 0, 3. I like to write those smaller to remind myself those numbers, those little red numbers, are never part of my final answer. They're just test numbers. Now let's plug those into the fraction that we had when we got everything all together. If I plug a negative 4 in for x in 2x plus 7, I end up with a negative value divided by a negative 4 in the bottom. Negative 4 minus 2 is also negative, and a negative divided by negative is a positive. Plugging in a 0 for the top, 2 times 0 plus 7 would be positive. On the bottom, 0 minus 2 would be negative. A positive divided by negative is a negative. And then a 3 in for x. 2 times 3 plus 7 is positive. over 3 minus 2 is positive, so that interval is positive. What we're looking for are values that are greater than or equal to 0, so those are positive intervals. I have a positive interval from negative infinity to negative 3.5, and then also one from 2 to infinity. So from negative infinity to negative 3.5, and then from 2 to infinity. Now, when you have the fraction, it's tricky with the parentheses and the brackets. I do have equal to, which normally indicates brackets. However, if x equals 2, and I put a 2 back into my fraction, 2 minus 2 would give me a 0 on the bottom. You're not allowed to divide by 0. So we can't ever have a value that is equal to 2. So the 2 has to have a parentheses. Now it's okay if you end up with a 0 in the top of a fraction. And because we have the equal to, the 3.5 will have a bracket. Infinity always has parentheses and a U for union. In general, if you can just remember, if it comes from the bottom, it can never be a bracket. The 2 came from the bottom part of the fraction, can never equal to. So if it comes from the bottom, it will never have a bracket. We're going to solve an equation graphically. So, if we're asked to solve an equation graphically, we'll use the graphing calculator. It's far too inaccurate to try to do this by hand. So it's time to get out the graphing calculator. And we're solving x cubed minus 5x squared plus 2x plus 6 equals 0. We want to graph that. So into the graphing calculator, you should see a button that says y equals. You're going to push that, and you're going to enter in your polynomial. So for x on your calculator, you'll use this button that says x, comma, t, comma, theta, comma, n. So that's the button you'll use for x. And then this little up arrow is the power button, so that's how you do to the third power. X to the third power, and then minus 5. I'm not sure what this thing is for. Minus 5x, and then here's the squared. That's what the squared looks like. Plus 2, x, and then plus 6. So those are the buttons you push to enter the polynomial, and this is what it should look like on your screen. Then to graph it, we just need the standard 10 by 10 window, and when you need that, you'll push the zoom button and then choose 6, which is standard. If, however, you're using an iPhone, that app, to graph it, you push the graph button first, and then you'll see zoom at the bottom, and you'll choose standard. So it's a little bit backwards if you have the iPhone. And this is the graph you should see. Now what I've circled in red are the zeros. Those are the solutions to the equation. And so we want to make the calculator tell us what those values are. If you have the iPhone, all you have to do is touch where that graph crosses the x-axis, and if you've touched it in the right spot, it will turn red. And so that will be the 0, and so you just do it at the 3 places where it crosses, and you're done. But if you just have the for real calculator, or you're using the Android app, you have to go through a lot more rigmarole to get those answers. So iPhone, just touch where it crosses. If it turns red, those are your solutions. You're finished. Everybody else, you have to keep going. And what we're going to do, the menu item that we need, is you're going to push the button second, and then the button trace, and then you're going to choose option number 2, which is to find the zeros. And when you do that, you get this first screen, and it asks the question left bound. And so you've got to know your left from your right. I'm going to first try and find this far left 0. And so you have to know your left from your right. So you're going to move your cursor somewhere to the left of that 0 and hit enter. Now go to the second little screen. It's asking for right bound. So I need to move my cursor somewhere to the right of the 0 and hit enter. And then the third screen, it's going to ask guess. Anytime the calculator asks you to guess, you just go ahead and hit enter. And then the final screen gives you that 0. And let's just round to 2 places. So this first 0 is at negative 0.86. And you still have to find the other 2. So you have to go through that process all over again. Go back up to the top, second trace, 2, and then you'll be trying to find this middle one. You'll have to go to the left of it, to the right of it, and enter. And then you do it all over again to find the third one. Go to the left of it, go to the right of it, and hit enter. So that's just repeating second trace number 2. And so you end up with these zeros, these 3 zeros. Negative 0.86, 1.68, and 4.18. And those are the solutions to that equation.